LangGraph streaming system surfaces real-time updates through a token-by-token emission mechanism, enabling responsive applications by progressively displaying LLM outputs before full response completion. This artifact demonstrates how to initialize a graph with a single node that invokes an LLM, then stream the generated tokens alongside metadata containing node-specific invocation details. The upcoming code will reveal a straightforward implementation where a StateGraph is configured with a data class-based state, a chat model is initialized, and a node function is defined to generate content based on the input topic. The streaming iteration then processes each token chunk with its associated metadata, printing the content as it becomes available.
From data classes, import data class. From LangChain, chat models import init chat model. From LangGraph, graph import StateGraph start. At data class MyState. Topic, SDR. Joke, SDR equals. Model equals init chat model equals GPT-4. 1 mini. Def call model state, MyState. Call the LLM to generate a joke about a topic. Hash note that message events are emitted even when the LLM is run, using invoke rather than stream. Model response equals model invoke. Role, user, content. F, generate a joke about state topic. Return joke, model response.content. Graph equals. StateGraph MyState. Add node call model. Add edge start, call model. Compile. Hash the messages. Stream mode returns an iterator of tuples message chunk, metadata. Hash where message chunk is the token streamed by the LLM and metadata is a dictionary. Hash with information about the graph node, where the LLM was called and other information. For message chunk, metadata and graph stream. Topic, ice cream. Stream mode equals messages. If message chunk content. Print message chunk, content end equals, flush equals true.
This code demonstrates LangGraph's messages streaming mode, which enables real-time token-by-token streaming of LLM outputs with associated metadata. The pattern is particularly useful for applications requiring responsive user interfaces or real-time processing of LLM outputs, as it allows developers to process and display content as it's generated rather than waiting for complete responses. The implementation follows a straightforward workflow. A StateGraph is constructed with a single node that invokes an LLM to generate a joke about a given topic. The key innovation here is the use of stream mode equals messages in the graph's stream method, which yields tuples containing both the LLM token chunks and metadata about the invocation. This metadata includes details about the graph node where the LLM was called, enabling fine-grained control over which tokens to process or display. The approach offers significant advantages for user experience, especially with high-latency LLMs, by providing immediate feedback. However, it's worth noting that this streaming mode is specifically designed for LLM outputs within graph nodes. For non-LangChain LLM integrations or more complex streaming scenarios, developers would need to use the custom streaming mode instead, which provides greater flexibility but requires more manual implementation. The code also highlights that message events are emitted even when using invoke rather than stream on the LLM, demonstrating LangGraph's consistent streaming behavior across different invocation methods. Let's break it down.
From data classes, import data class.
Imports the data class decorator from the data classes module, which enables automatic generation of special methods like init and repr for classes, reducing boilerplate code when defining simple data containers.
From LangChain, chat models import init chat model.
Imports the init chat model function from LangChain's chat models module. which provides functionality to initialize and configure chat-based language models.
From LangGraph, graph import StateGraph start.
Import StateGraph and start from the LangGraph graph module. StateGraph is a class for creating stateful graph structures, and start is a constant representing the initial node in a graph workflow.
At data class.
Decorates the following class as a data class, automatically generating boilerplate methods like init, repr, and ec based on the class's annotated fields.
Joke SDR equals.
Declares a variable named joke of type SDR and initializes it to an empty string.
Model equals init chat model equals GPT-4 1 mini.
Initializes a chat model instance using the GPT-4 1 mini model identifier. The init chat model function creates and returns a configured chat model object that will be assigned to the variable model. This sets up the foundational LLM component for subsequent chat operations in the application.
Def call model state, my state. Call the LLM to generate a joke about a topic.
Defines a function named callModel that takes a single parameter, state of type myState. The function's purpose is to invoke a large language model LLM to generate a joke about a specific topic, as indicated by the docstring. The function signature suggests it will operate on the provided state object, though the implementation details aren't visible in this segment.
Model response equals model invoke.
Invokes the model and assigns the response to the variable model response. This is a direct method call to the model's invoke method, which triggers the model to process input and generate output. The result of this invocation is stored in model response for further use in the program.
Role, user, content, F generate a joke about state topic.
Constructs a dictionary representing a user message that requests joke generation about a topic stored in state topic. The dictionary follows the standard message format with role, set to user, and content, containing the f-string that dynamically inserts the topic into the joke request template. This creates the input structure expected by LLM systems for processing user prompts.
Return joke, model response.content.
Returns a dictionary with a single key, joke, mapped to the content of the model response.
StateGraph myState.
Creates a new StateGraph instance using the myState class as its state type. This initializes a graph structure where nodes will operate on and modify state objects of type myState.
Add node call model.
Adds a node named callModel to the graph. This node will be part of the graph's execution flow and can be invoked during graph traversal. The specific behavior of this node depends on how callModel is defined elsewhere in the code, but this line simply registers it as a node in the graph structure.
Add edge start, call model.
Adds a directed edge from the start node to the callModel node in the graph, establishing that the callModel node should be executed immediately after the graph starts.
Compile.
Compiles the LangGraph workflow into an executable graph structure. This method call finalizes the graph definition and prepares it for execution, enabling the streaming capabilities defined in the graph configuration.
For message chunk, metadata and graph stream.
Iterates over a stream of LLM output chunks and their associated metadata from the graph. Each iteration yields a tuple containing a message chunk token or segment and a metadata dictionary with details about the graph node and LLM invocation. This enables real-time processing of LLM outputs as they're generated within the graph execution.
Topic: ice cream.
Creates a dictionary with a single key-value pair where the key is topic and the value is the string ice cream. This represents a simple data structure that associates the topic identifier with its corresponding value.
Stream mode equals messages.
Sets the streaming mode to messages for token-by-token LLM output streaming with metadata. This configuration will emit tuples containing each message chunk and associated metadata during graph execution.
If message chunk content. Print message chunk, content end equals, flush equals true.
Checks if message chunk content exists and is truthy, then prints its value followed by a pipe character, without adding a new line. The flush equals true parameter forces immediate output instead of buffering, ensuring the content appears right away in the stream. This implementation showcases LangGraph's token-by-token streaming capability through the messages stream mode, which delivers real-time LLM outputs paired with invocation metadata. The workflow begins with a StateGraph configured around a MyState data class, where a single node invokes the LLM to generate content based on the input topic. The key innovation lies in how stream mode equals messages transforms the graph execution into an iterator-yielding token, metadata tuples, enabling progressive display of LLM outputs. This pattern is particularly valuable for responsive applications, as it allows immediate user feedback even with high-latency models. The implementation also demonstrates LangGraph's consistent streaming behavior, where message events are emitted regardless of whether the LLM is invoked via invoke or stream. The trade-off here is that this approach is specifically designed for Lang chain-integrated LLMs. For non-Lang chain models, developers would need to use the more flexible but manual custom streaming mode.
Tokens spill like a broken pipe, yet metadata arrives wrapped in golden state.